Hi, today what we're going to be talking about is chemical equilibrium. So to introduce this topic, I have a little bit of a demonstration to show you. So the first thing that I have in this beaker is this pink or rosé color solution. And what this is, I took cobalt chloride and I added it to water and I made this solution. So what we have here is this cobalt hexa aqua complex. And I'll bring it closer to the camera so that you can see this pink rosé color. So before we get into this demonstration, what I want to do is I want to put up the chemical equilibrium equation that we're going to be working with this particular solution. So let me go ahead and go to the board. So the first thing that we have here is our cobalt hexa aqua complex. And what we're going to be doing first, I'm going to take a small amount of this complex, I'm going to add it to a second cleaned out beaker, and then I'm going to add some concentrated hydrochloric acid. And so for this equilibrium equation, we are interested in the chloride ions that are going to react with this particular complex. And so when this happens, we get an equilibrium equation, and this equilibrium equation will look like this. So in this equation, what it's going to happen here is we're going to add that hydrochloric acid, and these chloride ions are going to react with this complex, and this forward reaction is going to proceed. Now I should stop right there and explain, well, what are these arrows? Up to this point, we've seen chemical reactions that proceed in one direction. With chemical equilibrium, you almost have to think of it as two different reactions occurring at the same time. The first of these reactions is going to be from left to right, and that reaction is going to be known as a forward reaction. Now, something different with chemical equilibrium that we haven't seen up to this point is that a reverse reaction from right to left can occur. So these products that are formed can go through that reverse reaction to produce these original reactants. So let's go ahead and let's see this demonstration in action. So like I said, I'm just going to take a little bit of the cobalt complex here, the original cobalt complex, and then I'm going to add some concentrated hydrochloric acid to this solution. And I'm going to wait and see for a distinct color change. So now what I have done, I've added this hydrochloric acid, and I have produced now this cobalt tetrachloride compound. And you can see that it has a distinctly different color than what our original cobalt solution was. So it's that dark blue that we see in solution. And so before we do our next part of the demonstration, I want to talk about the chemistry of what happened here. So we had this pink color from the cobalt hexa aqua solution, what we did is we added some chloride ions via that hydrochloric acid, and we made the forward reaction proceed. What we see here and why we have a blue solution out in front of me is because of that forward reaction proceeding, we produce that cobalt tetrachloride complex. And so that cobalt tetrachloride complex is what is in solution. Now our last part of our demonstration is we are going to take some distilled water, and we are going to take and push the equation back or to the reverse reaction, and we're going to have the solution at equilibrium. So let me go ahead and grab the distilled water, and what I'm going to do, I'm going to add it very slowly because equilibrium will occur and reach very, very quickly. Now we have reached a distinct color change. Now what has happened is that we are now at equilibrium. This is our third unique color that we've seen in this equilibrium. And so this right here, this lavender solution, and I'm going to bring it closer to the camera, this lavender solution that has been produced is showing us that we are now at chemical equilibrium. And so just to show you that solution we've just produced is a little bit different, I'm going to compare the original cobalt solution to the solution that's lavender or at equilibrium. So you can see that they're two distinct colors. So our last part here that we're going to talk about here is the chemistry side, what that equilibrium means. So what that means is that we now have equal forward reactions as we do reverse reactions, and those concentrations of all of these complexes are staying constant. Now they're not the same, but they are staying constant at equilibrium. So I hope you've enjoyed this demonstration, and join us next time for World of Chemistry.